In a world where high-performance, zero-defect buildings are hard to find, two men are on a mission to disrupt the status quo. Welcome to the Edifice Complex, the Property Design and Development Podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague, official agitator, friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello, Yoda.
Today's guest will be an inspiration to all practitioners. He graduated in 2002 from the University of Manchester in the United Kingdom with a degree with honors in mechanical engineering. In 2006, he became a chartered engineer in the UK, and in 2010, a professional engineer in California. He's been a lecturer in MEP design at the Academy of Art, University, San Francisco, and in 2014 received the Consulting Specifying Engineer 40 Under 40 Award. In the following year, he was awarded Mechanical Engineer of the Year from PME Magazine. He also sits on ASHRAE SSPC 55, which is Thermal Environmental Conditions for Human Occupancy, and ASHRAE TC 6.5, which is where I got to know Mr. John Williams. So welcome to the show, John.
Thank you very much, guys.
So, John, your project list is pretty impressive. A new international airport for Mexico City, Mercedes-Benz Stadium in Atlanta, Georgia, Puerto Pedregal in Mexico, Apple Park in Cupertino, California, Apple retail stores, China, Canada, United States, Newport Beach Civic Center, the Shard London Bridge Tower Project, Northern Arizona University Applied Research and Development Building Flagstaff, and the list goes on. You have been a busy man. Tell us your story.
Well, it all started slightly by chance, really. I was living down in Kent, in Ramsgate, and about to finish my A-levels, and what do you do? So decided to think about that and got into engineering purely because I wanted to do the scientific side as well as something that was a little bit more hands-on and practical, because I've always liked getting to some sort of actual goal at the end of something rather than just a piece of paper. And so I went around a few of the universities in the UK and centered on mechanical engineering because that seemed to be the most general in terms of having a science basis. And then at the University of Manchester, they gave me this very handy little red book that they had, which listed all the companies in the UK at the time that offered scholarships. And so I took this little red book and I applied to every single company in the red book.
That's awesome.
And so, and this was from all sorts of fields. It was like aerospace, defense, and ended up getting an interview with O'Varup and Partners, as they were at the time. And they offered me a scholarship and a period for the university to come back and intern with them every summer following a gap year. So sort of completely by chance, I landed in the world of building engineering. And it was sort of, the interview for that was actually quite a funny story in itself, because I was there meeting this guy, his name was Mike Edwards. And one of the questions he started asking me, I was like, I slightly recognize that thing he's starting to sketch there on that piece of paper. And it was a section through a building. And about 3 to 6 months earlier, I'd sort of been up worrying for my, A-level mock exams and not really sleeping like I probably should have been. And I was watching an Open University program, which for those outside of the UK don't quite know what that is, but it's basically university through the television. And it was an entire program on this low energy building in Nottingham. And so I learned all about this fascinating building. It was the Inland Revenue building. And the guy interviewing me turned out to be the main designer for it. So we sat there and chatted for about 20 minutes about me having understood this building from this show. And yeah, the rest is history, really. Did university and started back at Arup after graduating, and then did London for about 6 years. And they said, do you fancy going to the USA? And I thought that could be an interesting challenge. And so I went to San Francisco. And then a few years later, really more for personal reasons, I sort of wanted a bit of a change again and to come to Mexico, where Mexico's such an interesting country. It's on the verge of absolute booming, and has been multiple times. And there's one of the things I noticed coming on my visits to Mexico is how much design there really is down here. People do really enjoy the design of buildings, but this level of sophistication available to, in particular, the architects isn't what you're necessarily used to in the USA or the UK. So there was clearly a market here. So I moved down and luckily met the company Parsons, who I'm with now, and they offered me a role as a senior project manager working for the new airport that's currently under construction.
Wow. So did you move down speculatively or did you move down for the job?
Well, I essentially moved down speculatively. I left Arup. They unfortunately had no work at the time down here, and went with WSP, who agreed that I could be this remote worker living in Mexico, partially looking for work for WSP in Mexico City. And that's also when I was working on the Mercedes-Benz campus in Atlanta. And it was sort of quite, geographically funny, because everyone was a bit like, oh, you're the guy that lives in the foreign country. And it was like, so...
with the foreign accent.
Exactly. But it was me living in Mexico, which was luckily only about like a 3-hour flight to Atlanta, whereas the rest of the team were all in San Francisco, and they had like a 5-hour flight from Atlanta and lived, 2 time zones away. So it was a lot more convenient from Mexico City to work on a project in Atlanta than it ever was from San Francisco.
Oh, that must have confused some of the Americans. A Liamie living in Mexico working on an American project.
Yes. Especially one who doesn't even know the rules for American football.
Yeah. I'm with you on that. It's chess with meat, right?
Exactly.
That's interesting. So, it warms my heart to hear you talk about the Open University, because I did technical college, and then when I realised I wasn't going to be a professional skateboarder when I got to 30, I thought, oops. So I finished off with the OU, and then I went to Greenwich for my master's. So I have a very soft spot for the Open University in the UK. It's the place where people who were delusional or need a second chance go. That's me. On both counts. But it's interesting also because I worked at Arup. I was recruited into Arup in 99. I worked for a year in New York on JFK. So I know what it's like to work for Arup. Arup was an interesting firm for me. It's a firm I'd known all my working life, and then I sort of got recruited in to do a job. And it was fascinating. The reason I said yes to it was because I was just fascinated to see what it was like on the inside after watching it from the outside for 20 years. And it was interesting because they don't bid for work, right? Work just arrives at their door because they're Arup. People just knock on the door and say, would you like to design this $1 billion building? They go, yeah, okay, we'll probably do that for you.
Yeah, we'll think about it.
Yeah, we'll think about that. So, it's fascinated me because they didn't bid for anything yet. Like, work just used to wash over them like a tsunami. And then you have a problem on site. Like, I had a problem with the fire engineering at this project. And I cabinet officer said, who can I speak to about that? And they go, oh, you need to speak to this guy over there. And you go over and see him, and he's the guy who wrote the book for the fire engineering you had the problem with, right? That's the way Arup is. They put this, and also when you leave, it's like, it's like they have this chip inside you, right? And you feel super guilty when you go.
Well, that is probably the reason I gave him 1 year's notice.
Now, John, were you around when Arup developed the Project OVE, where they modeled a lifelike building? It was taller than the Eiffel Tower, but it was in the shape of a human. Were you around for that?
I remember reading about it, but personally, I wasn't involved in it.
Yeah, that's again going back to the scale of the company. Where they'll, give a couple of young engineers with computer modeling skills. Here's a few $1 million. Just design a building in the shape of a human, but it has to be like 40 stories tall.
Yeah,
and let us know how that works out. And as it turns out, the graphics for it were phenomenal, and we've used it in our lectures because they looked at the structure as the bones of the body. They looked at the electrical systems as the nervous systems, right? The air handling system was respiratory system. The all the arteries and veins was the heating and the cooling system, and it really was a good example how architecture and humans form are really tied together?
But I think that was, for me, that was the analogy I always had in my head, particularly when trying to describe what I did to people who knew nothing about what we do.
Yeah.
Because I sort of got bored when I sort of first came into the industry on the mechanical electrical side, saying, oh, I work as a building engineer. And the first thing anyone says to you is, oh, so you do structures then? And I was like, no, I don't.
And the next question is, oh, you changed the filters then, right?
Exactly. Also, you like a mechanic. And taking it to a biological sort of analogy works for people.
Yes.
Because people do understand that, that all living things, whether it be, an actual, animated organism like a human or an animal, or even just a plant, structure is one thing. But people understand the difference between sort of a tree that, is not alive anymore and a living tree. So it was using that analogy of, what we do in building services is, basically putting the life inside of a building. Yeah. We make the building breathe. We make the building light up. We make the building, have some sort of level of sophistication and smartness through its control systems. And so when I went that path, people were a bit like, so there's a lot more going on, is there? And it was a good way of sort of like trying to get that description across. And then I remember the Arup model you were talking about coming out. And so that was a very sort of graphic representation of it. But I think the analogy works with or without the sort of the very attractive image in your head.
Yeah, I'll link an image to that in the show notes because that is very impressive. It's interesting as well hearing you say that you sort of wound up in building services by accident because, again, it's like me, I'm a commissioning guy and I work in building services. No one wakes up at 18 and goes, I want to be a building services engineer.
Exactly.
No one gets in a car crash and says, get me a commissioning engineer, I feel bad,
Not unless they're in some kind of psych ward.
Yeah, not unless they're on some good drugs. So the other thing that fascinates me about your story is this, right? So, if we go back in time to when you were at school and I lined you up with 10 of your contemporaries and I said to someone, right, pick out the guy that's going to work, going to get a degree, become a professional engineer, work in the UK, work in America, work in Mexico. Go, pick that person out, right? They wouldn't be able to do it. So, it's always a source of fascination for me that you can never spot the people who are going to get that breakout velocity, right? There's nothing wrong with staying in London and working your whole career in London. Nothing wrong with that at all. But what is it that drives people? You and I have a sort of a similar thing, really, where we've sort of broken out of our normal orbit and got into other orbits, right? And I've bounced around the globe myself. But, what drove you to leave the warmth and comfort that is the UK?
I think part of it is slightly just the opportunities that presented themselves. So a good deal is luck. Luck is like anything. Yeah. But also it's just that desire. Like I remember being in London and, I'd worked on a couple of towers there already. And I was working on the Shard at the time. And it was like some people like to call me hyperactive, which is probably true. And it was my boss literally said to me, would you be interested to move to San Francisco? And I was like, well, why not? There was just no reason why not to do it. And I suppose once I'd made that move and, I'm sure you understand the complexities with that in terms of then having to go back and learn the imperial system that, we've tried to abandon once and the different culture. Yeah. Just also how people, interact and get things done is extremely different. And so I enjoyed that challenge going to California. And also the buildings I've worked on were all very much ingrained in, what was initially, the green building style, then the low energy building style. And then it eventually turned into sustainability somewhere along the line. California was a real center for that. And I don't think I was even fully aware of that at the time, but sort of having that opportunity to be around, the folks in Berkeley and to really sort of get a deeper understanding of what was happening in, low energy and sustainable building design was such a unique opportunity. But again, it was sort of purely formed by luck rather than, great wisdom on my part.
Yeah, I've been the beneficiary of a lot of great time and luck, I have to say.
But I think fundamentally it's being open to the opportunity.
Yep, right. There's a difference, right? So the opportunity passes in front of several people, maybe only one will step forward and take it, right? That's the difference.
Exactly.
Yeah. So
embrace the pain. Yeah. I always say embrace the pain.
Exactly. And it's sort of, it's allowing yourself to be outside of your comfort zone for that little while.
Yes.
Like moving to Mexico now has been different challenges.
Yes.
Even if we just start with the units, they're still not quite sure which units they use here. Sometimes it's imperial, sometimes it's metric. So luckily I know both now.
Sounds like Canada.
Same as Canada.
So that's sort of part of it. But it's also, you come here and you've got to deal with a culture that is incredibly different, where there's a lot more hierarchy in terms of what people are used to dealing with.
Yes.
And sort of from my age perspective has been quite interesting for their mix, because typically here the hierarchical structure is just the guy that's been doing the job the longest, not necessarily who has the experience.
Yeah.
And here, because there haven't been that many low energy buildings, it's been quite an interesting sort of like culture to have to really sort of absorb and embrace, to sort of be like, yes, I might not be the oldest person in the room, but, you can have a bit of faith that I have done some of these things before. And so that's been like actually quite an interesting sort of challenge to sort of get across to people that, it is sometimes about, the technologies and innovations have moved on extremely quickly. Like I remember when I started sort of back in, whenever it was at Arup, sort of 20 years or so ago. And, even then it was just starting to change, but the first person the architect would call would always be the structural engineer. Whereas it was about 5 or 6 years into my sort of career that, that stopped. All of a sudden it was the mechanical engineer they wanted to speak to first, because they wanted to understand how they were going to get through these energy codes. They wanted to understand what the implications were to their systems, services, so on and so forth. And that was sort of like an interesting step, sort of like for what we went through in Europe, and USA was very similar. Whereas, coming here, it's probably about 10 years behind in that regard, where, the structural engineer is still king. And for certain very important seismic reasons, Mexico City is very specific to that issue. Yeah. But they also know here, like they have, very, significant air pollution issues just with the population of the city, which is now, bounces somewhere between 20 and 30 million, depending where you draw the boundary.
That's insane.
It has the energy issues, it has water issues. So within Mexico itself, there's a real strong driver to get more people involved in sustainability and really getting a passion for it. And I think before I came down here, I'd met a lot of those people who were touched by, sustainability in different parts of their worlds, that I really felt that passion has begun here. And in fact, actually, today, which is quite ironic for our call, is the first day of Greenbuild's first ever Mexico exhibit happening today, which was the end of the week. And so that's being fully integrated between SUME, which is the local sustainability sort of chapter for USGBC here in Mexico.
Excellent. Yeah. It's funny, Adam and I have talked several times about, operating businesses. We both have owned and sold businesses. And, we were talking about hierarchies, and we, in our business, had a very flat organizational structure. Mm-hmm. We never saw silos. We saw that in order for us to achieve what we needed to do quickly and professionally, that we needed a flat structure. And so that's how we grew our business, was a flat structure. And then we sold the business to a small Danish company called Danfoss, and who aren't small at all, for those that know the name. And in their North American operation, the executives there, forced us to go and restructure ourselves into a hierarchical system. And within 2 years, it collapsed. And I think when we look at sustainable, the term sustainable and what that means in terms of business practices, that the flat organizations are critical to that. I mean, I don't see the philosophy of sustainability being a hierarchical thing. It has to be integrated. It has to be flat in order for it to work.
It has to be multidiscipline, right?
Yeah.
Well, I think we can even go beyond that. It's like, to me, it all comes down to collaboration and how collaboration is allowed. As I said, it was like, back, in that sort of 5 years into my career stage, they call the mechanical guy. But it's like the mechanical guy isn't enough anymore, because then we're just really thinking about energy and sort of like the fundamental uses, which were mainly HVAC related. But now, to get the real sort of like the deep green cuts that you do need mechanical, electrical, plumbing, a sustainability expert, the landscaping person, the architects,
interior designers,
more specialists, who can, really help you out. Actually, the one that always gets me, that's always forgotten, is the acoustician. Been thinking about an interesting problem lately, and it's sort of like, I'm working sort of like with teams here that are a lot more very much in uni-discipline sort of cells, so to speak, and they struggle with that sort of collaborative nature. And then one of the things I've been chatting to with sort of a close friend of mine who's more in the sustainability sciences world is, like, you mentioned, like, cross-disciplinary, or is it, interdisciplinary, or where they want to take it in pure sustainability science is transdisciplinary, and in transdisciplinary, there's no walls whatsoever. But most importantly, they try and come up with a way of, really facilitating the conversations and the discussions such that nobody ever feels that they are, putting a face forward to represent a certain idea, so that it just allows completely free speech. And then the person that's leading such a session or facilitating it has to come up with some sort of strategy to filter out and funnel through the best ideas from this group of different experts of specific disciplines. Now, I don't think in the building industry we've made it that far yet, but I think it's a real goal that we can get to in terms of having, the best buildings out there. Because at the moment, we still occasionally will, fall back to our sort of our comfort zones, whether we like to or not, to say, okay, we will just do what we have to do, whether that be, heating or cooling a building, getting the lights turned on. But the other thing that's key to all of this, and I think this is where your flat structure comes from, is these conversations have to be happening all the time, and in particular, up front in the design. Nothing here can happen sort of later on or afterwards. So that's sort of something that is, in terms of what happens in a project's development, how do we allow ourselves to make those decisions in the right time and in a timely sequence?
Yeah, that's interesting.
Yeah,
because when you talk, I love that new word you've just introduced to me. It's new to me, which is transdisciplinary, i.e. no walls between disciplines. Now, that concept is integrated design process, I guess, right, to translate that.
But it's to the nth extreme.
Yes, to like the absolute, Tourette's level, I can say what I want and that's it, no filter, right?
Exactly.
Let's call that Tourette's design. That's my version.
There you go.
Now, the issue with that is cultural, right? So I've worked in the Spanish culture before. I did a job in Spain, in Tres Cantos, Spain, for Glaxo, way back in the day, like in the early 90s. So I go there, and I'm representing Glaxo, so I call a meeting. And I say, we're going to meet at 3. They'll go, okay. I go there at 3. I'm the only guy there. And then I go, maybe there's a misunderstanding. So I call another meeting for the next day at 3. They go, okay. I go there. I'm the only guy there. So I asked someone, well, what's going on here? He says, oh, no, you've got to say you want them on time. So I have to say 3 o'clock at the English hour. Then people will come. So I learned was, there's a hierarchy. There was one guy I wasn't acknowledging his awesomeness, which was one of the problems. The other problem was I wasn't absolutely clear that I wanted it on time. And the word for that was on the English hour. Changed my life for the rest of my job, that did. So it stopped me talking to myself.
You can imagine that. I have quite a few similar stories here in Mexico, which comes from a very Spanish culture in certain regards.
So also, I would say in Mexico, there's a lot of status issues, right? There's a lot of class issues. There are everywhere. They're just more obvious or not obvious, right? So, trans-disciplinary or Tourette's design, how does that work in a Spanish culture where there's hierarchy and seniority abound everywhere?
I think it works because there is a passion.
Right.
People want to see Mexico as Mexico can be. Mexico has so many opportunities. It has a wealth of resources, a wealth of abilities. So I work with, all of my team is Mexican, and they are fantastic engineers. And it's just about sort of like educating and talking about how things can be done differently. And at the end of the day, I don't think it matters about what class somebody's in or any of those sorts of things that live outside of the work or the office place. People want to see Mexico do well. People want to see, Mexico as a country, grow to the success levels that it really can do. And I definitely feel that on the project I'm working, where, everybody from the MEP side and from the sustainability side, is looking to use, all the best technologies, lean on sort of international firms as necessary to bring in sort of more specific skills, but then really adopt them and absorb them into their daily practices. Now, I suppose one of the things that will need to happen, and, it needs to happen, I'm sure, in every sort of everybody's life, it becomes generational almost. Yeah. It's like at the moment I sort of see here, that the touch paper has been lit, and people want to do it. There will always be people that believe, how things have always been done are the best way. But we know that in every culture and every life.
Yes. Right.
But I believe there's enough emphasis and onus here that they know that the eventual goal and the true, the real outcome is what's going to stand the test of time.
Yeah, absolutely. Now I'm interested, just for our listeners to put it in context. So Mexico City has a population approaching 30 million. The total population in Canada is 37 million, I believe, at the moment.
Something like that, yeah.
And Canada's the second largest country in the world, FYI.
Yes, landmass.
Yeah, landmass country. Most awesome. Number 1, by the way. I'm saying that as a Canadian now. But anyway, the scale of that as a mega city, right? So Mexico is one of the emerging mega cities, which is a global trend, right?
Yes.
So you're designing an airport. I've worked in 1986, I'm old, by the way. This is what you should know. And I worked on King Khalid International Airport in Riyadh. So that was a massive, it was a bit ahead of its time. It was designed to be like a tent structure, which translated to a massive architectural shell. And that was done with district cooling and ventilation coming in at the ground and, using stack effect. So fast forward to the year 2000, I work on Terminal 4 in USA. Massive, it's designed to look like a wing, but the effect is just a massive hall, using stack effect. District cooling, air, right? So that's not a lot of change there. Architecturally, it looked awesome. Engineering-wise, it was the same. We had Peter Simmons on the podcast a little while ago. He's very famously for being one of the designers on Bangkok International Airport. And he managed to implement a radiant cooling solution and displacement ventilation, of which I am a huge fan. So my question to you is, in a very long way, what are you doing down in Mexico?
So here the designers have chosen to go for displacement ventilation only.
Okay, that's a start. I like that.
And the main reason for that here is really the climate is fantastic.
Yeah.
like, though we do have pollution issues, and that's one of the things where really trying to do some deep analysis now as to what is the best air infiltration strategy we should be proposing for the airport, because that becomes a bigger issue when you have such outdoor air pollution.
Yes.
Like everyone talks about indoor air quality or indoor environmental quality for a building. But, in a place like Mexico City, and I don't know if you know, but the city is surrounded by mountains that causes this inversion effect that pulls the pollution down to ground level in different times of the year. And so because we have that condition, it's like, how do you improve the internal quality of the spaces when the outdoor is so bad? And it's sort of given us some real challenges as to what should be done there. So we're looking at a number of technologies now that we think are best to implement over the long-term period to make sure people can really enjoy that space. Now, we had conversations as to whether that should be, potentially, radiant or just displacement for this building. But with the amount of hours we can use just an airside economizer from, it makes a lot more sense here that you can just blow the air in as and when it's needed, assuming the building has enough shading and other bioclimatic design features as it does. So that's sort of what took us down that path. And I think it's definitely a good solution for it. But I think what a lot of people forget about Mexico is, or Mexico City, is we are about 1.5 miles up in the sky. Yes. So one of the interesting factors there is, the air here is about 20% less dense. So it changes a lot of those calculations that people typically have to do in terms of calculating fan energies. And really, these cities, 1 mile or more in the sky, don't have a huge amount of technical backup support at the moment in any of the codes and standards, which has been quite an interesting sort of challenge, or indeed in the softwares for calculating the psychrometrics correctly. So that's been another challenge that we've been looking at to sort of really understand, from an energy perspective, is this really the best decision? It's been very hard to make those decisions quickly because you've really got to go back to some of the first fundamental principles of, the building science and the building physics to really make sure that what we're doing here meets all those things that we are naturally tuned into saying as engineers, that's the right decision from day one. That's
really interesting because the solution for bad indoor air quality is more outside air. Right.
Yes, exactly.
And, when you're in Mexico, that can be a bit of a problem, right?
Yes. So getting that balance right and the filtration has been a real judgment call. And how that ties in with the control systems is something that, I think we will be refining and working on, a long way through construction to make sure that we're getting all those sensors in the right place so that we really understand what we're bringing in from outside.
Also, you got pollution but it also, from planes. Sorry, Robert, go on, Karen.
Yeah, no. But it also emphasized the importance of making sure that you have a tight structure and with the openings controlled, doors coming in and out, right? All of that access. But ultimately, with such bad air quality, you want to have a low infiltration rate and that any air coming in has to be filtered.
Yes, exactly.
That's a key component, right?
Yeah. So, and that brings us to another point that, again, is one of those things that, we are faced with different challenges here. The construction industry for Mexico has, for a long time been, this is how we build things. It's a lot of it's punched windows, and we all know the problems with sealing those sorts of construction types. So a lot of the what we consider now pretty standard commercial construction techniques in terms of, curtain walling or other sort of facade systems are sort of having to come into the market to really help that air sort of infiltration, exfiltration story get improved.
Right.
But this is, again, something where the contractors are having to become more sophisticated than what they've worked with previously. Mexico has the biggest sort of stockpile of cement in the world, and sells it everywhere. So concrete is a big deal here. People love to pour concrete, because it's a national resource. So moving to some of these more sort of advanced, innovative technologies for the facade systems is sort of a little bit of a challenge at times to convince people that is the best way to go. Maybe
the solution should be a heavy mass concrete solution, right? Somehow you got to make it beautiful. That's the tricky bit, right?
Yes.
I'm thinking the TWA building in JFK, right?
Yes, exactly.
Something like that. Because I've worked on a very low energy, heavy mass concrete building with radiant heating and cooling in Canada. It worked, but making that look pretty and non-industrial was pretty damn tough.
Yes.
Yeah. So, Adam, we have a few more minutes left, and I wanted to ask John about his advice for the young engineers coming out. John, you've embraced the world of modeling software, and that's something that you don't get taught in school. I'm got to be thinking the software that you're using is not something that you see in school. And I know that for a fact because you were a chair of one of the research committees here that I sat in on for one of the ASHRAE publications, research project software. Can you maybe talk a little bit about modeling software, skill sets that the young engineers should be working on, and where do you see modeling going?
So I think modeling is going to reach a point where things do start to come together. Like, I'll be completely honest, and I'm sure you guys are the same. I'm not sure what they learn in school anymore. It's probably very different to what I did, which was all still blackboard and, learn the calculations. But I think one of the things I found most interesting is I was sort of taught, from HVA perspective, 3 fundamental pieces of software. The first being sort of comfort software. So, in terms of trying to design spaces with, either peculiar shapes or, lots of glass with lots of sun gain, will these spaces truly actually work? Because often, the bulk mass air temperature doesn't really tell you anything. Yeah. So those comfort softwares really taught me a lot about understanding whether a space was going to be successful. And then I spent a lot of time then in sort of 2 or 3 different energy softwares. Now, the energy softwares themselves would also work for different systems in different ways. We used sort of some quite simple software when we were first trying to do the Part L, which is the UK building regulation for energy compliance, sort of back in the day, just to get sort of basic, sort of almost prescriptive compliance that, your fans are going to use a certain amount of energy, your HVAC system covers the basic loads. And then other softwares like IES's virtual environment have taken this on. And then, everybody was always waiting for DOE's Energy Plus to be, the one that was going to nail it with a nice smart interface. And then the other sort of major strand of softwares that we've all been getting more familiar with is obviously BIM and Revit.
Yes.
And, I think I'm still waiting for those 3 major strands, especially from a mechanical design of buildings. And you can easily add to it for, lighting design with radiance and plumbing design for their pipework systems. How do we truly allow BIM? Because it really all turns into building information modeling to have these add-ins for calculation such that people can use one piece of software, because often it's jumping between the different pieces of software that, honestly becomes a skill in a way.
Yes.
I was working on a building in San Francisco, down in Cupertino, and to do that building, we had to do comfort in one system. We did most of the energy modeling using IES's virtual environment, but that wasn't sophisticated enough for the internal systems within the building. So we did that with Energy Plus, and then we had to post-process it all with the results from IES to come up with this total number.
Right.
And so you end up having to use up to 4 or 5 different pieces of software to even really start understanding how you think a building will behave. And that takes a lot of experience of the different softwares and sort of also just the fundamentals. But even though I love the software, I think one of the things I'm keen that the young guys never miss out on, and girls, we have many girls these days, is, nothing beats doing some hand calculations.
Amen.
Somebody being able to put together a spreadsheet and have, okay, this tells me basically what I know I'm going to need. This allows me to do some sort of conceptual understanding of the spaces of the designs so that you always have that back check. It's far too easy, even with the individual softwares where you can sort of understand to a closer refined level. But as we move towards this, potential, this marvelous software that does everything, the biggest risk I see is that, we could potentially descale younger engineers from being able to back check their own work. And I think that's something that we have to make sure as an industry that we really sort of like keep everybody engaged as to what is technically important and what is sort of like just extra beautiful analysis that doesn't really give us any benefit at the end of the day. Because, nobody wants to do analysis for the sake of doing analysis. We are in this industry to build a building and for that building to be comfortable and, have good lighting and to, for people to fundamentally want to be in it and more productive within it, as opposed to having some lovely colors on a diagram that will be forgotten,
That was a famous statement by Peter Simmons. He called CFD colors for directors.
Exactly.
Yeah, that's right. When I think about our practice here, 3 formulas: one, calculating the load or the flow of energy through an enclosure, calculating inside surface temperatures, and being able to determine flow rates, either air-based or fluid-based. It's the same formula for the flow rate stuff. 3 formulas that you can use, simple stuff that allows you to back check. So I look at all the fancy programs that are out there, and at the end of the day, I want to know 3 things.
Yes.
What's the flow through the enclosure? What is the inside surface temperature? And what do I need to do to replace that flow, either with air-based or fluid-based systems?
Exactly.
Right?
And we just want it to work.
Right.
That's the important thing.
Yeah.
The Edifice Complex will continue in just a moment. If you're enjoying this podcast, we need your help. We're not asking for money, just a minute of your time. Our goal is to make the Edifice Complex podcast as relevant, educational, and useful as possible. By having good ratings, we can reach the widest audience. Therefore, our request is 2 small things. If you haven't already, leave us a review and rating on iTunes. And subscribe to the Edifice Complex on YouTube, even if you normally only listen to the audio version. These 2 things will help us immensely. Also, if you would like Robert or Adam to speak, teach, or consult on your project or business, please email admin@edificecomplexpodcast.com. Thanks for your time, and now back to the show.
You hit some really important things there, right? So back checking your work, one of my early Obi-Wan Kenobis mentored me on that. He said, always back check. Even if you think it's right, take a minute and check it, right? You can do that with a simple calculation. And the other thing is, we're designing it to work, as you say, right? Software has the nasty habit of stealthily de-skilling you.
Yes.
To the point where you're almost like, it's like Stockholm syndrome. You're like a cult member at some point. You're a virtual reality cult member. You've got to be able to step out of that and have a practitioner's fundamental check.
Yeah.
I'm not saying that because I'm old and I can't do virtual environment, because I can't. But, there is, it does horrify me a bit when I see total devotion to the software outcome.
Yeah.
And I think the other thing that sort of like I found very interesting in my career, and I think I've been very lucky to have these different strands, is I was never pigeonholed as either the modeling guy, the guy that can go and sit in meetings and chat to the client, or the person who can be on site doing construction work. And I think it's having those different, sort of outlooks and understanding what the different needs are from, concept with the architect to, construction at the very end, coming into the commissioning phase, and the client is wanting a building that works, that, every single decision you make along that path can affect your end eventuality. So we've got to make sure that all the young engineers that come in are given that breadth of skills so they can truly service their clients.
Yeah, agreed. So you're designing and constructing a massive, let's say, airport. It's going to have a shelf life of 30 to 50 years, right?
Yeah.
Now, I'm a big fan. I'm in the current cargo cult of the Internet of Things. So my belief is that the cost to monitor performance and measure and make adjustments is falling exponentially, right?
Yeah.
And I think that's going to have a profound effect on building operation and design. Now, if I was designing an airport today and I was king of the designers, I would be putting as much measurement capacity into that building via the BMS as possible. Is that a strategy you're going with
Yes. No, we have, the building is going for LEED Platinum. And so that helps us a lot of the way in terms of even the credits we picked. We picked to go for the advanced commissioning credits and all the advanced energy credits,
right, and
also the advanced water credits, based on we know the issues that exist really here in Mexico.
Yeah.
So we do have, we have all the water metered down to different levels and different areas of the building. We are metering power through a dedicated power management scheme. We have that also. One of the things that's interesting for me about an airport terminal building is just the number of stakeholders.
Yes.
Now, and that is something that's so fundamentally different than most buildings. Like a lot of commercial buildings can have different users, but they're all sort of doing pretty much the same thing. If you've got 20 stories of office, you've got, probably 18 stories of all commercial office layout.
Yes.
Some of them may be a bit dense, some a bit lighter, but you can make a pretty good guess. Whereas in a terminal, you've got every sort of user under the sun. You've got the airlines with their offices, you've got, catering facilities, beverage facilities, you've got the baggage handling systems, you've got all sorts of other back of house spaces, you've got government facilities, security facilities, and all these different users have different needs, requirements, and usages. And so really doing that, in particular on the power side, because it does come down to the electrical, that most of that user will see the variation on. And elsewise, it's really the HVAC, but we're monitoring that at the units that are generally dedicated per different user group area. And so using those two systems, we'll be able to, really sort of get these different users to look to optimize in the future.
Yeah.
Now, one of the most interesting schemes we have been developing down here is the US Department of Trade and Development, the USTDA, gave an award to do a sustainability management plan. And so what's been super interesting about this is actually for the airport in operation before the airport's even opened. So we are now writing the plan of how not just the individual buildings, but the entire 5,000 hectare site will develop sort of between its opening date and sort of its full master plan development that takes us out to about 2065, that we make sure that this airport stays on track to always be, one of the most sustainable in the world. So I think the fact that, we are thinking now during construction about how operations should be run, and not just in the major facilities that is so easy to be distracted by, yes, but also these other facilities that also be very significant, such as hotels. We've got cargo facilities, we've got maintenance operations that will all keep needing more and more users and usages. How do we make sure that those future operators, because we don't know who they are today, how do we keep them on target, on a goal, so that, that initial ethos that comes from, typically the master planner or the architect, and that was, 3 or 4 years ago already, doesn't get lost somewhere in the process.
I mean, the numbers are just staggering for an airport on that scale, serving a city on that scale, right? It's just
ridiculous. It essentially is a small city.
Yeah. So we're coming up to the end. We always have a few closing questions for the Obi-Wan Kenobis that we interview, all right?
Okay, good.
Consider yourself Obi-Wan Kenobi for the next 10
Thank
minutes.
you.
So what advice would you give for architects? Like if you were given, like you parachute out this job, you're parachuted onto a brand new project and you have power. And what would you advise the architects going forward, or any new graduating architect? What's the one thing that could change their perspective or life?
I would just encourage the architects to always ask questions, and not just ask questions of their seniors, but to ask questions of their consultants, to really get into that team mentality. All the best projects I've worked on have been often when, I've sat down with an architect for an hour and we've just discussed what the building systems should be or could be.
Yeah.
And then the architects can go off, do what they do best, which is, sort of like more fundamental design work a lot of the time. But if they've been given those fundamental constraints, you're going to end up with a far better design in the early stages than you ever would than if the architect just goes and does their thing without asking those questions first.
That's good. So same question for engineer, a graduating engineer or an engineer on a new project you're working on.
So I suppose one of the things that kicks into my mind with this is sort of where some of life is today. We've all heard about it, the millennials, Generation Y, and I've had a few of them in my time. Yeah. And it's, don't think you know everything. And, when you're asked to do a task, sort of grab it by both horns, see the task as being an open-ended opportunity to complete the design if you really want to. No senior engineer above you is going to be disappointed if you do more work than you're asked to do.
That is awesome. Yeah. No one gets fired for over-delivering, right?
Exactly.
There's a life lesson, guys. Just take that
there
away.
You go.
End.
Yeah. That's
See,
really
I'm
good.
such a misogynist. I say guys and girls. So this very quickly, a subject dear to our heart on this podcast is women in engineering. I deliberately do not use the word STEM. I'm talking about engineering here, right? So I think Arup were all very progressive with this. There was a lot of female engineers there. So any particular advice for women in engineering?
I think for women in engineering, it is a challenge. There's no two ways about it. It's like there's still, and I even find sort of part of this just being a bit younger. It's like the client wants to see, a grey head or, a few wrinkles around the eyes in their engineer. Yeah. And so it's very hard for women to sometimes give across that perspective of how is their experience? Did they really get their hands dirty and, pull up their sleeves to understand, what it takes to connect two bits of copper? It's that sort of mentality that, people don't necessarily get. But I think what I've seen is that women do have it harder. There's no two ways about it. Even though I've had my challenges, they have more challenges. And I think that they are often smarter than a lot of, the guys in the room. And I think what needs to sort of happen is that, really it has to come from the engineering side. It has to be the leaders in engineering today who, give the younger and sort of middles and juniors, women engineers out there, a lot more face time with the clients, so the clients can have, that confidence in them that they truly deserve, and there's no question about that. But it's like the client doesn't necessarily know that unless they're sort of given that at this point. And so we need to do this generational change again. And this is something where I think this is a world level, and I have some fantastic women engineers on my team here. In fact, my lead for storm design is a woman engineer. And the things that she knows in her head automatically and her attention to detail are things that I miss in a lot of my other engineers on the team. Yeah. So it's really absorbing those other skills that are there.
Yeah, I agree with you. It is harder to be a woman in engineering, but in my experience, everyone I've ever met has been absolutely awesome. And formidable sometimes, because they do break through that perception barrier sometimes, right?
Exactly. Yeah. And I think that's actually one of your points. It's like sometimes you've got to be seen to be a bit forceful, particularly when you get to the construction end of it.
Yes.
And it's harder for women to be seen as positive if they're seen to be forceful. Yes. And that is something that, you know, sometimes it's like, and I've actually sat there in some meetings and I've been like, you know, come on, guys, everybody shut up. Listen to this woman. Yeah. She's the one that knows. And if anybody speaks during her, we're both just going to leave. Because, you know, if you don't allow the person with the knowledge in the room to speak because, you know, you don't see them as being forceful enough, then that's a problem for the project. And that's a problem for everybody sat in that room. It's not the woman's problem. And that's something that, you know, as a lesson we all have to learn and take away.
Actually, that's a great point. Yeah, that's well said. Opportunity cost to the project and to the team, right? If you're not listening.
Oh, totally.
Yeah.
Yeah.
Yeah, well said, actually. Very well said. I like that. I like that as well. You know, it's hard to be seen positively if you're being forceful, but sometimes as a woman you have to be forceful, right?
Exactly, but it's something that is, but often then from a personal level, they're looked down upon. Yeah. And that's what isn't fair. So it's this balance that, you know, women are given from their, you know, their stereotype, you know, in terms of our, you know, our biases, that if a woman is seen to be forceful, that there's something not quite right there. And that is something that, you know, we as people have to either get over, or the other way is that, you know, we as, you know, men can all take a leaf out of women's book and say, well, why do we have to shout and argue about this one particular topic rather than actually just trying to get to the best solution for everybody involved?
Oh, yeah. The management by shouting culture, that is just so prevalent in our business.
There's a skit on YouTube. It's a comedy skit, and it's a game show. And, you know, so the question gets asked, and the one guy who answers first and correctly is marked wrong because the guy next to him was louder. He was, you know, right? Yes, Stu, you're right, but unfortunately you're wrong because Timmy over there was much louder than you were.
Yes.
And I like him.
and I like him.
Yeah. Hashtag life's not fair.
Yeah. Welcome to the real world. Yeah. That's sad. Okay. But that's some great words to end on, because, you know, and certainly women that do step up, understanding the challenges, do well. Ultimately, I think, you know, I mean, I don't know, John, if you had a chance, but Adam and I interviewed an engineer from Mexico, Cecilia. And we brought on a psychologist to join us in the interview, just to work through some of the things that Cecilia faced. And, you know, Adam and I were concerned at the beginning, that's why we had April on it, that the interview would have been a negative thing. But you know what? Cecilia, all the stuff that she went through, she was positive, she was motivated, she was passionate, she had clarity in her thought and where she wanted to be. And it was actually one of the most inspiring interviews that we've done.
Yeah.
Good.
Awesome. Yeah.
Yeah, she was great.
Okay, John, look, we're going to wrap up now. Where can people see you on social media? Have you got a Twitter handle, a website where people can see your work or follow you or track you like a stalker?
Yeah. Where can people stalk you?
So I'll put your LinkedIn link in the show notes. So have you got a Twitter handle?
Yes, I do. I don't use it very often. And it's JG double DOUBLE and then a single U. So JGW. Okay. To match my initials.
That's good.
Awesome.
Engineer.
And is there a website for the project where people can have a look at it? Because, you know, with some of these big projects have webcams and websites because they're so enormous, you can see them from space type thing?
There is. I'll have to dig that one out for you, and I'll email that afterwards. That's
Great. And I'll put that on there because, I mean, what an interesting project. Big capital projects like that fascinate me because these are intergenerational projects, right? You're making decisions that are going to outlive you. It's crazy. Yeah.
Could do.
Yeah. Until we get to synchronicity and extend life, which is probably not far off. That's another podcast. Anyway, John, thank you so much for coming on. That was awesome. And I find that project you're working on absolutely intriguing.
Well, thank you very much for having me. It's been a great fun and nice to sort of reflect on some of the things you do. We probably don't take enough time to do that either in our careers, do we?
That's very true. All right. Hope to see you in Houston, John.
Unfortunately, I won't be making it this time. I've got some meetings that have come up, but I will see you in the winter meeting.
Excellent.
All right. Thank you very much.
Again.
Thanks so much, guys.
So what did you think of John? That was a great interview, actually.
Yeah. I mean, he brought up some really good points, several of them. One of them, which I really liked, was putting life into the buildings. You know, when you look at the electrical and mechanical engineers, that they actually do put life into the building. I mean, there's the architectural form, there's the structure, but those are static elements. But when you look at lighting systems, security systems, the plumbing systems, the HVAC systems, that's what brings the building to life. I really thought that was a good way of looking at the profession.
Yeah, you think, right, you go into a building. So most airport buildings are impressive, just for sheer scale, and most of them look pretty nowadays, right? Yeah. So you walk in, but the minute you walk in, that fades, right? You're in that envelope, and what matters next is how you feel about your comfort, your space, your air quality.
Yeah.
Everything, the experience becomes prime at that point, right? And that's the undersold thing in design. The experience of coming up to that building is one thing. The experience of being in it for 2 or 3 hours, which you inevitably are if you're flying international, that is in the realm of the building services engineer, right?
Yeah. Yeah. And he made some other good points, you know, how the evolution of, you know, green and then sustainable, how the focus has moved not away from structural engineering, but a more focus on the mechanical and electrical system. So, you know, in traditional building, it was the architect, and then he would hire the structural engineer, and the two of them would work out the building. And then when that was all done, then they would get a hold of the mechanical and electrical guys and say, okay, now make our systems work or make our building work. But now it's more integrated, where the mechanicals are brought in, the electricals are brought in to look at the environmental systems and the energy systems. And that's actually the way it should be done, you know?
It was interesting. The thing that I thought about when we were talking about that was the incentive structures there have changed, right?
Yeah.
So the architect is actually very well incentivized now to have a wider team around him early because of code requirements, certification requirements, and award requirements, right? Now, there are awards for green buildings now, right? Who doesn't want one of them on your wall?
Sure. So on your resume, right?
It was before, sort of back in the day, sort of in the 80s and 70s, it was about how it looked way more than how it operated, right?
Yeah. So what did you think of the term trans-disciplinary, a.k.a. Caraviola, Tourette's design strategies?
Yeah. So when he said trans, first of all, there's a guy I follow on Instagram who does these great imitations of the Kardashians, and it always starts with the guy who had the sex change, the dad.
Right.
And he always talks about being
Bruce
trans.
Jenner.
Yeah, Bruce Jenner.
Yeah.
He said, it's good being a woman. It's lovely. And I'm going to put the link to that guy in the show notes. So when he said trans, I immediately went to that. And then when he explained it, I thought, it's like, because I've worked with some architects, right? And in those meetings, everyone's on their best behavior. They're sitting to attention. They want his attention. It's like, you know, it's like having Darth Vader say, okay, you may now speak. Right. Yeah. But what you need is the Tourette's thing where you can just say, what's on your mind? You know, he could be pontificating about something. You can say, dude, that just won't work.
Yeah.
There has to be the environment where the mechanical electrical engineer has to say, I'm sorry, Sir Norman Foster, but that just is not going to work. So let's just stop that right here, shall we, and talk about it. Right. But, when you're in a room with Sir Norman Foster, is it possible to say that?
Yeah. And that's a lesson not just for the building design process, but for all businesses, that having people as yes people,
Yeah.
where they're always, yes, we can, yes, yes, yes. And the guy that comes along and says, no, you can't. He's the sand in the ointment, right? But you have to listen to those people. And you know this from running a company, and I know this from running a company. Not the most valuable, but one of the most valuable people on your team is the guy who challenges you. Even though you're the owner, the boss, you're signing the checks, you want people to tell you when you're off base.
Yeah.
That's the check. And that's why you hired those people. And I think that's one of the fundamental differences between a good business and a bad business is that the good business is owned by somebody who recognizes that I'm not going to hire people who are dumber than me, because then we're always going to be the most dumbest company going. If everybody under me is stupider, dumber, less motivated, that's a recipe for failure, right?
Absolutely. But
if you hire guys that are smarter than you, more passionate than you, more motivated, you want them to tell you when you're off base. That's why you hired them. So let them do their shit, right?
So there's a humility that's required, right? Great leaders are humble.
Right.
Because they can take advice.
Yeah. So good architects and good engineers, I mean, one of the good traits that you can develop is make sure you don't surround yourself with yes people. You want people who will challenge you, tell you when you're wrong, or tell you that, we can maybe look at this at a different angle and optimize it, right? And be open to those suggestions.
It was interesting to hear him talk about Arup, because that was my spirit at Arup. It was the most collegiate, sort of like intellectually stimulating place I've ever worked. You could not help but bump into geniuses everywhere you went. It was ridiculous. I felt so dumb when I worked there. It was so inadequate, but it was one of the great work experiences of my life as well.
Yeah, he slipped in a bit of wisdom that I want to bring out, and that is, and I kind of paraphrased. I said, who's holding up progress is the person stuck in the status quo.
Yes,
right.
That's a t-shirt there.
Right, and he mentioned it it was in the conversation, but he talked about people doing the same thing over and over again, and because that's the way they've done it, and yet those are the individuals that hold up progress, right?
Yeah. You know what? I just thought we should get some t-shirts going. That'd be a great t-shirt. That really would.
I thought his words on modeling software were really good. It reminded me, there's a Professor Mark Bomberg. He's kind of a legend within the building science world, and he's taught all over the world. But when he was at the University of Saskatchewan, and he was telling me this at a dinner, he would tell the students, you can't touch the computer until you know the answer. Yeah,
that's great. Then you're just checking your answer right. I like that.
Yeah, he says any engineer worth his salt has an intuition of what the solution is when faced with a problem, and you're only using the computer to facilitate the calculations, but you should always know what the answer is before you sit down and use it. I thought that was brilliant.
That's profound, because the exact opposite is happening. I'm seeing everywhere I go.
Yeah. So you probably really associated with his comment about the multiple stakeholders in airports, eh?
Yeah, I've done a lot of airports, not by design, just the way it's panned out, and they are super challenging jobs. As you said, like the stakeholders, like the job I did at JFK, it was just ridiculous, because you've got like the immigration people there, you've got the police there, everyone's there wanting everything and wanting it for them. They don't care about the other bits. The flight information people, and then, so commissioning that building and integrating all them systems was one of the most challenging things I've ever done. And they are unique. And just if you say like JFK, for example, right, that airport's going to be there 50, 60 years, and then it'll be knocked down, that building will be. So that thing is going to be consuming energy, consuming resources forever, right?
Right, yeah. Yeah.
And that's some, so a bad decision can compound for 20, 30, 40, 50 years, right?
Right.
Conversely, a great decision can compound 30, 40 years, right? This is why the design process is so important. And this is why somehow linking the design process and consequences to long-term operation, I think, has to happen. Now, people will say the P3 process is doing that. It is to a large degree, actually. That is one of its successes, I think.
Yeah.
But, it's so easy to be in your bubble and like, okay, I'll just copy and paste, get this out, and then forget about it. And then that thing sits there for 30, 40 years, consuming energy, right? That's the consequence.
Yeah. He also made a comment which and I didn't mention it because we didn't have a whole bunch of time to get into the politics that right now. So this is 2018 for, these podcasts are going to live in forever. So the year is 2018 and the U.S. political system is under turmoil, to say the least. Very much an internal, let's put up, the walls. We're gonna look within our belly button, and that's where life exists. But yet, John, working in Mexico, receiving awards from U.S. recognized organizations, is just another illustration how sustainability has no borders. Right? You can put up all the walls you like around a political system and an economic model, but ultimately buildings that are built in Mexico, or whether it's in Venezuela or in Canada, wherever around the world, has an impact on the world. And I think despite the efforts of political will to shut that world down, they can't. They never will be able to. That's because engineering and science has no borders, right?
You can't. I think the global economy is so interconnected now, and people are so interconnected, and ideas are so easily diffused. You cannot put your borders up anymore. You can't be an island anymore. It is impossible to be an island anymore unless we have a major event that shifts technology back 50 years. But that airport is unique. What I came to realize as we were having that conversation, indoor air quality, Mexico City, right?
Yeah.
A mile in the sky, that airport, surrounded by mountains that create massive air quality problems.
Yeah.
You're at an airport which has, by definition, massive air quality issues, right? You'll normally wind up with special filters for anything airside, right? You're bringing air from airside. They have to have carbon filters. The filters where they filter out all the smell and that.
Yeah, the odor. Yeah.
Yeah, I can't remember what they're called. They cost a fortune. That I do know. And so, your control for temperature is possibly not, and comfort is possibly not as important as your control algorithm for indoor air quality.
Yeah.
So there is a hierarchy there that is sort of inverted, right? So normally most airports control for temperature, humidity, maybe ppm, right? Now, if I was just, without thinking through too much, if I was designing the control algorithm for that building, air quality, you have to somehow have a measurement for air quality, then occupancy ppms, then temperature, then humidity, then control maybe. I don't know, right? But there is some that is not going to be a copy and paste solution, whatever they implement there.
No, and so if you think about air quality alone, you're going to have to filter out particulate matter, and then you're going to have to filter out gases, and in those gases, of course, are going to be some odors. So those three things right there, and then you've got humidity control and temperature. So when we talk about heating, ventilation, air conditioning, the AC, I've always thought AC was the wrong term. It should be CA, conditioning the air, because when you say AC, people automatically think cooling, right? Yeah. But the reality is it's CA, we're conditioning the air. So in the terms of the odors and gases, all of the different absorbents that are available, like you can't just say okay, we're going to put in a activated carbon filter, because activated carbon filter will work on some gases, but not all gases. Like formaldehyde, for example, is not quite, it does work, but not as great as some other materials. So the engineering of the filtration system is not, as you said, not a copy paste. That is an engineered filter, because they'd be looking at, okay, what are in Mexico City? Let's do a long-term study, or take data from a long-term study that says, okay, this is what's in the air. And we don't want that crap in the building, so we're going to filter it out. And so then we have to engineer our filters based on that, right?
And the cost of them filters, man, total cost of maintenance of them filters over 30 years. My goodness.
Yeah.
You'd have to have a ticket tax of $5 per head just to pay for that, probably.
Yeah. Well, in your world of the commissioning, right, and then recommissioning systems, part of that is going to be looking at the pressure losses through those filters, because there's an implication on energy on that, and then plus those things have to be regenerated, right? It's not that they, you take those things out and you have to replace it with a new device. So that means that every gas filter has to have a standby. Right, because you're going to take the one out, put the new one in, and then go get the other one regenerated, cleaned out, and then bring it back to the site. So when they're bidding on the jobs, they have to allow for those replacement filters. So it's interesting.
The answer to that problem, I think, is a massive living wall somewhere, right?
Yeah, maybe.
I'm fascinated by this job now. No, it's unique. I mean, LEED Platinum's hard at the best of times, right?
Yeah.
And with its unique design challenges, that job is fascinating to me. I hope he said, when we get the link for that, I'll put it up and watch that place, because I know how hard airports can be. But
yeah. So what did you think of his answers to the question? If you had advice to, his first one was ask questions.
Yeah.
What do you think? What do you think of that?
I think that's right. Ask questions. That when I started back in the day in the early 80s, there used to be a thing on some drawings. There was a firm in the UK called Hayden Young, who's been bought out now, but they were like the gold standard of MEP contractors. And they always used to put a note on a drawing: if in doubt, ask. In other words, don't put this freaking thing in unless you're sure it's right. So what they were saying, it's a bit like the Japanese car production line. If you think something's not right, stop it. Don't just forget it, right? There was some power in that. And at the time, for a long time, they were the premier MEP firm. And I'm not saying it's just down that one thing, but that was an example of the culture they were trying to, imbue, right?
Yeah.
So I love that. And that's so, because I came into the industry as that was fading out. I still saw that and was exposed to that. And I've always carried that with me. If in doubt, ask.
Yeah, I don't know if our audiences, some will appreciate how important that is, because when you put that kind of a statement on there, you're basically saying we take responsibility for this project to the extent that we're saying to you that you have the power to come back to us. If something's not right, we want to know about it because we're going to take responsibility for it. So many drawings have, these are illustration only, and basically, you're on your own. Yeah. If you, it's not our problem if what we design doesn't work. It's your problem because it says right on the drawings. Those are completely two different statements.
See, the weasel clauses on drawings and specs drive me nuts.
Yeah.
Shall be this, and anything else we can't think of, you've also got to cover.
Right. Yeah.
That is in every clause, and that is just BS.
Yeah, not limited to, and shall include, but not limited to.
So that's the one. Yeah. Yeah. That was written by a lawyer.
Yeah.
And if you put that in your spec, F you is all I got to say to you. Now I've retired. Because you are a asshole if you let that go out in your spec.
Yeah, it's you taking responsibility for your, and that's what professionalism is all about. Yeah. What his comment on engineers, for young engineers, is, anybody that's got no hair or gray hair, we learned it's important not to think you know it all, because you don't know shit. Even when you're old and gray and bald, you don't know shit. So, his words, don't think you know everything. What do you think of that?
I like that. It's a humility thing, right? Because it is so easy when you walk in, like, you got the grey hair, you got the experience, and they look at you and you think, yeah, I'm just awesome. I'm the man. And you wouldn't be human if you didn't think that for a little bit, right?
Yeah.
But the trick is the real professionals get over that and allow their mind to open to, the nerd in the corner who's just run the calcs while you were sitting there pontificating and thinking. You can see the confusion coming over their face and you think, oops, have I just said the wrong thing,
Yeah.
Now, a narcissist just powers through and shuts that guy down. A real leader lets that guy speak. Or girl.
Absolutely.
Right?
Yeah.
See, I'm so programmed to deal with men in my business. I always say guy, right?
Yeah.
It's just something you grew up with. I always try and catch myself doing that, but it's hard, right? Because just about 90% of every person I've ever interacted with in my work life has been a man. It's ridiculous, really.
His on that same question, he made another great statement, which was, "No one gets," or I think you paraphrased, "No one gets fired for doing more than asked."
Yeah, that's right. Yeah, you want to get promoted, just do great work.
Yeah.
Someone who worked for me said, "Look, Adam, I did this, and you know what? I went a little bit further. I run these calcs, and this looks great. What do you think? Am I going to fire that guy or girl? No.
Yeah.
I'm going to think you're awesome.
Yeah, absolutely.
Maybe you're having my job. I might have to control you a little bit, but
yeah.
No, but that's the secret, right? If you want to do well, excel. You don't have to do the basic. Do more, right? Over deliver.
Another T-shirt. If you want to do well, excel.
Over deliver, man. No one gets fired for over delivering.
And then the last comment about women, I'm glad you brought that up because that is a area that we are passionate about, getting more women into the field. He made some really good points about, the it's going to take a couple of generations to get through this. But he did make, some comments about women pay attention to detail. He had one engineer that he works with that the detail that she had in her brain was phenomenal. He did say that oftentimes, or more frequently, maybe I'm putting words in his mouth here, but that women were smarter, or that he had women that were smarter in his team than the men. And I thought that was, because that's been true for me too.
That's my experience completely. Yeah.
Yeah. Yeah, the women engineers tend to be smarter than male engineers. And part of it is they had to work so damn hard to get to where they were, right?
That's what Margaret Thatcher used to say. She said, to do what I do, you have to be twice as good as the next best man around you.
Yeah.
And that was back in the 70s, right? Where that was absolutely true. What he said was interesting, though. Hard to be seen. If you're a woman, it's hard to be seen positively without being forceful, right? So if you're like, to get noticed, it's almost a catch-22. To get noticed, you got to be forceful or maybe over-aggressive. And then people think, it's hard to see that positively. But it's such a dilemma, right? It's such a dichotomy. You got to, sometimes, I don't blame women for being forceful and like elbowing their way in. They have to sometimes. Yeah,
and you're absolutely right. And he made probably one of the most profound statements in the whole interview relating to that was that it's not the woman's problem.
No.
It's the men's problem, and as soon as men grow up,
get over themselves.
Get over themselves, they'll be able to embrace women in the engineering team and understand the true value that they bring, their perspective, their knowledge, their skills. They worked as hard, or like you said, twice as hard as men do. So stop getting in their way. Yeah. That's just. And so it isn't the women's problem; it's the male problem, and we've talked about that before. And I think one of the things that we need to do as an industry is to teach the male engineers these important aspects, these cultural aspects that we're faced with, challenges.
I think so, and there is an element of generational stuff here, right? As the baby boomers start to leave the industry, I think things will change for the better in that department, right? It's a bit of a catch-22. There's a lot of experience leaving the industry, right? And a lot of mentoring leaving the industry, but there's also a new attitude coming in behind it. Yeah. Which is a good thing.
Yeah, absolutely.
Yeah. So on that positive note, I think we need a T-shirt section to our website is my main conclusion here.
There we go. I like that.
Okay, man. That was a good one. I shall see you on the next one.
Adam, again, always a pleasure, man.
Take care.
See ya.
Bye.
Take care. Bye.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. Also, if you would like Robert or Adam to speak, teach, or consult on your project or business, please email admin@edificecomplexpodcast.com. See you next time.